How's it going, Lone Riders? It's Andrew back with another video. This week we are going to talk about how we manufacture the top box and some updates around the design, so stay tuned. If you're new here, we make videos about how we develop our products. We get input from you guys in the comments down below, and we build those back into the products. So if you have any ideas when you watch this video, let us know in the comments down below. And while you're down there, subscribe and hit that like button. It helps out a lot. So with that said, let's just jump into the computer and check out this brand new top box and also how we actually produce this thing. Okay, at this stage, we are right in the middle here, metal prototypes. To get here, we go through many stages, but I'm going to outline the whole system and how we develop these prototypes right here now. So we start with CAD, and that basically builds us the whole product in 3D space, so we can work out all the problem shooting and develop this product right down to the closest nut and bolt. After that, we go into the card and 3D printing. So we use card in this instance because a top box is it's sheet metal, so we use card. It represents that quite well, and it's easy to form and easy to make into sizes. After that, we generally do plastic prototyping. It's because what we can do is we can laser cut that out and fold it and bend it, and it's kind of rigid, and it's easy to manipulate, so we can actually cut it and grind it and get it into form very quickly. And that's the next stage after the cardboard stage. This stage is important because that gives us we can bolt things onto it, and we can do more with it. Just card is generally just volumetric models and making sure that we're kind of getting our sizes right. After that, which we're about to start now with this design, with this top box design, is the metal prototyping. This takes a few more weeks to develop, and it costs a lot more to develop this stuff. So after the first 3 iterations, now we're ready to get into the more costly and invest more money into this. So here what we do is we develop this product in hard metal, and then we can actually test this on the bike as well. We can actually crash the bike and crash the parts on the bike and really give them a good test, find out what's interfering on the bike to the product and all this kind of stuff. So that's why we develop this kind of metal prototypes. After that, there's a small stage, which is a very big time-consuming stage. That's DFM. It's designed for manufacture. I'll cover that in the next slide. But that takes a lot of time. And then from there, we invest a lot into tooling, and we buy these tools, and we make custom-made tools to be able to produce the first tooled prototypes. Essentially, the tooled prototypes we're trying to figure out how the material works in the machines, and we try and get a consistent product or consistent part, because it's not so easy. Sometimes plastics are quite tricky. They shrink with temperature, different rates and stuff like this if we've got thick parts, and we're just trying to finish up all these. It's tricky to get all the tolerances perfect. So that's what this phase is for. It's essentially making sure that we have a prototype or a working model that's functional and it can be mass produced. After that, we get those samples back from the tooled samples, and we test them. We make our very small adjustments, millimeter size. Generally, it's around the closures and the locking systems and stuff like this, the more mechanical areas. And then we ask for a golden sample. And this golden sample is essentially just what I agree on and what the factory agrees on to make. And this is the standard. This is all the parts in there. This is what's involved, and all the different parts that we put in. And this is we basically design in these requirements into this product. So I have a copy of this, and the factory has a copy with this, and then we base our development, we base our production off that. I'm showing you the other production here. This is not the top box. This is the Rackless system, but I had these images available to show you, so I just use those. But we'll do this also for the top box. So after the golden sample here, we go into series production or batch mass production. So everything's signed off, tools are made, everything's signed off, all the quality controls sorted, supply chain is locked down, and all the contracts are signed, and then we go into batch production. So the DFM part I was talking about before is called design for manufacture. There's many words for this. What we're going to do very soon is design the product for manufacture. That means basically we want the parts to work inside tools. For example, if you look here in the gray area, it's a very rudimentary volumetric size. So we know the parts there, we know that it needs to function, and we know the sizes are accurate enough for it to work, but that would never work in a tool. We cannot use this. It's just pointless. So what we do is we we design it like the second image here, and we really work on thicknesses, and it's quite complicated to do this. So we spend quite a bit of time making the part come out of the tool. We have to put draft angles on everything, and that what that does is allow us to make this part over and over and over consistently and high quality. So that's essentially the next stage. Another thing what we do here is we reduce parts, and it allows us to really reduce a lot of parts. This is the Rackless system that we've just launched, and this will be getting delivered to clients soon. Essentially, it's finished, but this is a good example of our V1, how we developed it, round 1, DFM, and then we've got V2. V2, we reduced it by the weight by 14% and the parts by 42.2%. So that's massive, and that means a lot because it reduces the cost, it reduces the shipping time, it reduces the complexity, it just makes everything simpler. So the easier it is, the better the product. So the more simpler it is, the better the product for everybody. So that's what we're doing now also with our metal parts. It's kind of like revolving all the time. It takes a lot of time to do this, and we're talking millimeters. If we're out a millimeter on anything, it's going to block something or make an edge sharp or something like this. So that's the details we're in at the moment. During the time we're doing a DFM, we're doing an RFQ. An RFQ is a request for quotation, and this is or a request for information. You can also, this part is essentially asking suppliers for how much a part would cost and if they can even make it, or if they have recommendations on what they need to do to change this. If they recommend that we use a different material, or the tooling or the design won't work, it's too expensive. So what we do is we send off this request for a quotation to the suppliers, and they give us a quote and cost. So we have our suppliers, we also have our factories that we work with all the time, but we still send this out and work with other suppliers just to make sure that we get the best possible price, we get the newest technology, and we get new ideas and problem solving. It's really important for us to have the best factories because that stipulates everything. That stipulates quality, that stipulates cost, that stipulates logistics. That's essentially the heart of everything. If you have a good supplier, everything else goes much, much, much easier. It's when you're producing in large volumes, only a small percent can be niggly. We have to change and update products all the time. It's natural, it's normal, things go wrong. But if you have a good supplier, we are way, way ahead of the game. So I'll show you what an RFQ looks like. And this is, so let's have a look at an RFQ. So this is an RFQ. I've kind of like removed quite a bit of this stuff just to make it consumable, and this is a very simplified version of it. We can go on, there's whole systems out there like software SaaS systems that does this, but for this kind of small project or this kind of size project with only several people working on it at the same time, just a Word document is definitely fine and enough. So the RFQ is just educating for a start. So you've got to think that somebody on the other side of the computer or is going to get this quote, and they're going to, or the request for quotation, and then they've got to understand this product as well. They might have no idea about motorcycles, but they definitely have an idea about injection molding or metal bending and stuff like this. Generally, our factories know what we do. That's actually not the issue, but that's how I write these things. I write these things out, so it's very simple. We go through a request for quotation. We send the 3D folder with the step data. Step data is just a CAD folder, so they can use it, and the hardware and everything we want to use. So it's a specific DOM of information that we send out to add in, and then I add in a bill of materials. Bill of materials is super important. It's just like a spreadsheet, and it gives you, it breaks down all the parts, all the materials used, what version they are, their names, their codes, the finishing on them, the surface finishing, core materials, and how they're produced. And that gives us all the tooling costs and part costs and everything like that. So this is one of the main things that you have to send with. I do a production forecast as well. So here I'm going to ask for 4 prototypes, for example, and 10 golden samples. Those 10 golden samples actually will go out to influencers or our professional riders to test them as well, and those professional riders will do their thing and destroy my products and give me feedback about how to make them better. But at that stage we've already tested it, so it's just another level of testing. And then our final product, we actually give quantities, forecasts, because when we're manufacturing, we don't manufacture in small batches. We forecast out several years. We try to, and that gives the factory a bit of confidence in investing in tooling and time and everything like that. So that's why we do a production forecast. Warranty info, packaging. We explain everything right down to the detail, the packaging, how it's actually produced. There's some blacked out images here because we're quite far with that as well. And then I go into the description of the product and what it is. And here, again, I tell you that these guys might not know what this product is. Well, they will. My factories do. That's not a problem, but I always make it very simple so everyone can understand on a very basic level. So yeah, then I go into the CAD product, and if you notice here, I've actually removed all our logos and stuff like this, and just done a very basic replica of our product. And this is just for security reasons. This is so so we can get a pure cost and pure quote through, and not a kind of any kind of biased quote through. And plus the design is a bit manipulated, so we don't put our design straight out there. It's a bit protected. So as you see, it doesn't have the multi panels and stuff like that. Even though I'm showing you guys on the YouTube here, and it's open, we're happy to share that with you because it's our unique design anyway. But when you're dealing with factories and the competition out there, they can get in there and use this data against us. So I just filter out this stuff. It just makes it simpler. We've got the rack plate and different size, and then I explain of how it's actually put together, the metal parts, how we glue it, just really an oversight on how to manufacture it, or how we expect it to be manufactured, welding points, how many welds there are on the product, where it's welded, and also the plastic parts, the injection part molded. So this is a very overview kind of sheet, but in the detail in the CAD and in the bill of materials, it goes into deep detail about what this product does and how it works. So yeah, that is essentially our an RFQ. The next one is we worked on the backplate and we wanted it to fit with our existing products. We've got the Overlanders here and we've got the Explorers here. And what we needed to do was make sure they integrate with our rack plate. The thing is, it can't integrate. We want it to integrate without, you want to be able to remove this bag and put the top case on afterwards and not remove stuff and fiddle around. So to join the bags to the back plate, I'm going to use the simple method that works really well. This is, for example, the MotoBags quick release system. And then here we have kind of like a G-hook, and here it's called a webbing keeper. What happens is that goes through the slot here, and then it pulls down and it locks in place. So that means that we can add another part, which is reasonably cheap, to the bags or to the top plate, and then we can offer everyone the option to have the top case or the soft luggage as well, without interfering with the mechanics of each. One of the steps was the cardboard prototyping. So this is it here on the bike. So this is what we mean by trying to get our volume. So there's no mechanical stuff here. It's all just printed out. There's some 3D printed parts here to get the volume and stuff like this, but that's what we do. We chuck it on the bike, and we also test with helmet. If you see here, we've got 2 helmets, and one of the big requests was putting 2 helmets in there. And these are 2 adventure type helmets. So they've got the beak on there. And we're thinking, we're kind of like in between what we should do here, because I think most people don't have 2 adventure helmets. If you are riding 2 up with your wife in the back or whoever's on the back, generally, well, in my experience, what I've seen is the main rider, the rider has a peaked helmet, an adventure style helmet, and the pillion, the passenger, just has a normal helmet without the beak. For many reasons, I know why, but they generally have that. So we don't want to make such a massive box that it just looks out of place, looks terrible, and a nice big target. We want to make it as compact as possible because we reduce materials, reduce space, aerodynamics, and all that stuff. It just had positives when it's smaller, it's lighter, and all that good stuff. So what we're trying to do is find the optimum size, and that helps with this cardboard model a lot. So the cardboard model worked really well. We got to see that it works with 2 peaked helmets, and we actually had extra space, so we can actually reduce it by 30 millimeter. 30 millimeters, only this much. Doesn't seem like much, but when we're dealing with this kind of volume, this small volume, it looks way out of place. So now we get into design. This is a couple of renders I made from the CAD. These are really quick renders. I didn't even bother. I just chucked materials on. So don't judge me. What you do with these renders is just to visualize the materials and stuff like this to give a really basic overview. If you notice, if you're rendering in 3D, what's best is to fillet all the edges, and then you get the nice round light reflections up here. Like this up here, you see it's dark and light. So if you have that on all the surfaces, 100% of the surfaces, you really get a nice kind of like a pop in the product. But here it looks kind of one color here, looks kind of dry. So that's why it doesn't look optimal. But yeah, this is the design we are at the moment. We've redesigned everything. It looks really badass, I think. It looks really good. That's from the back. And this is also... we're still working on the material for this back multi panel here, trying to find the best one. We've got to figure out strength, lightness, and rigidity, and try and mix all that together. We've got a few ideas, but that's not defined 100% yet. So that's from the back here. We've got a backrest here, the two-part backrest. The idea here is I wanted the back protector to kind of slot in, and then have a bit of an edge, so if it hits, they have a bit of support in the back there. This is real plush. This will be made out of kind of really soft material, beautiful material. We're going to focus a lot on trying to get this really soft for people. Even with back protectors and stuff on, people seem to get pain in this point, in this part. So we definitely will focus on that. That's from the back edge there, and from the top, and directly looking at it from the back. So yeah, that's the design update. Now we've really focused on trying to get this design a little bit more advanced and designed to the point where we can actually ask for an RFQ. And we are close to actually finalizing everything here on this design. So yeah, that's it. That's how we do the RFQ. That's how we do the prototyping, and that's the design update. If you like that kind of stuff, there's a link in the description, the first link, and that's to sign up to the newsletter that we send out bi-weekly emails about the product development, amongst other things. So sign up there if you want to be notified, and also subscribe. If you like it, subscribe. Push that bell icon to get notified when we do upload. And hope you enjoyed that. That's the latest update. We'll be coming back soon with a new update when we get a bit further with the quotations and going into tooling and stuff like that, more testing. So thanks a lot. Catch you soon.